Okay, we'll start the same problem. $60 kilonewton per meter, 100 kilonewtons. It's a 3. It's a okay. So directly see how we will solve. Directly, degrees of freedom is what? So 2. What is that? Theta B and theta C. If you give notations like A, B, C. You already know theta B is released, theta C is released. So only 2 degrees of freedom is there. Only 2 degrees of freedom is there. So no need of any another matrices. Just take is only those two only. Okay. See, now we can see how we will proceed. If you arrest those two, also, it is like fixed end beams. So fixed end beams mean what? Everything is fixed means what? Degrees of freedom is 0, kinematically determinate. That's the idea. If you see, if you arrest those two also, there is no degrees of freedom. That is a kinematically determinate. So that is a kinematically determinate. Kinematically determinates. If you arrest, that is also. You already know what is those. This value is what? This value is 80. This is also 80. This is 37.5. This is 37.5. We already decided. So clockwise, anti-clockwise, you can decide it. Anti-clockwise taken a positive, okay. Otherwise, clockwise take as a negative. Otherwise, anything. Okay. So that's it. Kinematically determinate. Now we can see. So no need to write a flexibility matrix for individual elements. No need to assemble. Just taken only. Finally, we have to get it only 2 by 2. So those are the two, or these two. Only na theta B and theta C. So just directly form the stiffness matrix by these 2 degrees of freedom. This is going to be asked mostly in examinations. Everything they ask, find out the stiffness matrix for this element, for this frame, for this spans. They ask like this. That means only they were interested only 2 by 2, not those 4 by 4 and 6 by 6. Not. So what is that, sir? What is that means? If you see, this is okay. So only degrees of freedom is. So this is theta B and theta C. So you have to develop the 2 by 2 matrix. Finally, you get a 2 by 2 matrix that you can directly get it. How, sir? How it is? See. Apply a unit rotation here. Theta B. See. Apply a unit rotation here, theta B. Arrest everything. Arrest remaining is arrest everything in here. Everything is only theta C only. Only 2 degrees of freedom is there. Give a unit rotation here. And find out the force developed at that location. Here also develop what is the force developed here also. K11. Okay, K21. You will get it. So later you develop a unit rotation here. You give unit rotation here. That is K2 and 2. Here K21. Get the force here. Get the force here and here. That is the 2 by 2 matrix. That is the only. If you remember those matrices, that's okay. But in that remaining matrix of 2 by 2 also, the meaning is same. The meaning is what it is. What I said now, the same meaning. Are understood? So directly no need to take a 6 by 6 or 4 by 4 deformation, 4 degrees of freedom. No. Here, total problem. What are the degrees of freedom? Theta B and theta C. Take those 2 degrees of freedom only. You will get it. If you applied a unit rotation here, find out the force generated here and force generated here. That is a stiffness. So next, if you applied a force, if you applied a unit rotation here, find out the force generated here and the force generated here. If you give a unit rotation at one location, arrest the other locations, arrest everything. Okay, that is they develop the stiffness. So now you can see, if you take in a clockwise or anti-clockwise, your choice. Now I will show you clockwise or anti-clockwise. What is the difference? So I will show you clockwise. That is your choice. Already I shown what is anti-clockwise. I already shown you. That's why I prepared here as just clockwise. That's the only idea. Otherwise, if you try it anti-clockwise also, stiffness matrix doesn't change. I said na. So see. So clockwise is positive. I taken as a clockwise is positive. So then if you feel these are the positive. Are understood? Clockwise positive. Taken like this, very small change, nothing is. See, now you can see. First you have to apply a unit rotation at theta b. This length is 4, this length is 3. Unit rotation in clockwise direction. So unit rotation in clockwise direction, how it is going. Here unit rotation. So arrest everything. Here also arrest everything. Then only you will get a force here. If you arrest only, they will get force. If you release it, nothing you will get. So see, unit rotation, clockwise. So how much force generated here? How much force generated here? Tell me here. How much force? Generated? You already know, yeah. You already know. How, sir? So for this unit rotation, if you just divide it like this, for this unit rotation, they required at least 4EA by L. You already know 4EA by L, because everything remaining is fixed. Everything we closed it. For this unit rotation also, it required 4EA by L. Stiffness, you already know it. 4EA by L is required. So for the generation of unit rotation at theta b, because it is jointed between two spans, it requires total amount. Okay, it joined between two spans. To getting unit rotation, it requires total this value, total amount required. Understood? So to get a unit rotation here, we required 4EI by L. L means this L is 4. For this span, 4EI by 3 it required. That is a K11. To get a unit rotation here, how much force generated? Or otherwise, to get a unit rotation, how much force is required? If you give a unit rotation, how much force generated? Both are the same. Okay, so that's what, how much it is. So you already see it's a 12, 4 outside, 3 plus 4, it's 3, 7 by 3 EA. That's it. And the same thing, how much force generated here. How much force generated here? Only degrees of freedom is there, only 1 and 2. So if you write it, this is taken as 1, this is taken as a 2. 1, 2 nodes. 1, 2 degrees nodes, not. It's 1 and 2 degrees of freedom only. Okay. So next take is K12. How much K21? The deflection is given in this direction. Kiz, you write it, Kiz, force at I by deflection at J. Okay. So K21, how much it is? You already know here, because it is a 4EA by L. The same, half of the amount is generated, half of the amount is transferred to this amount. That's it. So for this span, it requires 4EA by L. It transferred to the only 2EA by L. Not 7 by 3 EA. This is the total amount we have to transfer off. No, you already know moment distribution method. Same, Are understood? Already we discussed the moment distribution method. How much force transferred. If you applied in a giant, you already know. If you applied a giant minus 20 here, something plus 30 here, the half of the transfer here. For this half, it's transfer here. Moment distribution method, we already discussed. For this total giant, 50 is required. We add 10, 20 here, 30 here based on the stiffness. Half of the 10 is goes to this, half of the 30 goes to like this. We already discussed in moment distribution method. Same thing. Here is a 4EI by L applied for this span. 2EI by L goes to this direction. So that is 2EI by L is 3. 2 by 3EI. That's it. That's it. That's it. Okay, that's it. Next you will try for second. Next you will try for second degree of freedom. Give unit rotation here at second degree. So you take in a clockwise, na? You take in a clockwise rotation is you require like this. You arrest everything here also. You arrest everything, because see, you arrest everything, then only force will generate it. You arrest here also, clockwise unit here, you arrest here. Okay, so how much force is required? It's a 4. It's a how much is required? 4 EI by L. 4 EI by L. L is what? L is 3. So how much is transferred to this giant? How much is transferred to the, how much force generated at this location? So 2. So I write it as a K 2 is 4 EI by 3. K now 1 2. K12 is what? K12 is same 4. So that's what? It's a 2 EI by 3. That's it. 2 EI by 3. That's it. If you check it, is the same matrix will came at the end of those previous problem. So no need to take this 4 by 4 and 4 by 4. You add it 6 by 6 and you delete the columns and rows. You will get that 2 by 2. Those 2 by 2 directly you can take it as, like, you assume only 2 degrees of freedom is there. So directly take those 2 degrees of freedom is 1 and 2. Find out the stiffness matrix for the 2 degrees of freedom. That is the idea. Are understood? That is the idea. For the 2 degrees of freedom, you have to find out the stiffness matrix. You applied a unit rotation one giant, arrest other. If you need 3 is there, if you give unit rotation one location, arrest those 2. Find out the force generated at another at those three locations. You can find out like this. So that's it. Now you can write a stiffness matrix. How? So 1 stiffness matrix is 7 by 3A. It's a 2 by 3 EA. It's a 2 by 3 EA. It's a 4 by 3A. So only, and everything is positive. Everything is clockwise taken as a positive, and clockwise rotation. For that rotation is only clockwise. That is the stiffness matrix. And also this is a fixed end matrix. What is that fixed end? These are the fixed end. Everything you have to find taken as a determinate, kinematically determinate. For that kinematically determinate, force matrix is what? Force vector is what? This is theta B and theta is theta C. See, everything is okay. Force vector is what? Force vector theta B at this location C, at this location theta B and theta C. Only na? So taken a positive, clockwise is positive. This is 80 is positive. 37.5 is a negative. Okay, take it. 80, 37.5. That is the location. Na? This is the location of theta B, first location. So is equal to the 0 0. You already said why it's are 0 0. Why it is 0 0? Those theta b and theta c are released. Theta b and theta c are released. Finally is 0. This is when we taken as everything is arrested or kinematically determined, you will get it. Or later if you allow those rotations, it will to add those, you will get finally 0 0. Because at the joint there is no moments. At the joint there is no moments. If any joint moments is there, you will get like here, because at finals there is something, but now there is no final. Here final moments is 0. We already discussed previously. That's it. So 80 minus 75 here what is it? Here anti-clockwise. Here this is also clockwise. This is also clockwise 37.5. That's it. If you take in a clockwise is positive. Otherwise if you take an anti-clockwise is positive. This nothing is changed. Nothing is changed. This nothing is changed. Everything is same. These values will give negative signs, negative or positive signs. Sign will change. Finally you will get theta b and theta c same. If you take in this positive, anti-clockwise is positive or clockwise is positive, related to the same thing. You will relate it to the same thing. Okay, now we would solve it. Sir, how we will solve? Yesterday I shown you. Doesn't change at all. Same matrix. Doesn't change at all. Same matrix. You will solve it and you will get theta b is minus 11.875 by EA. Theta b is minus 22.18 EA. Sir, why it is negative? You taken as a clockwise is positive, you will get negative. Negative means anti-clockwise. Anti-clockwise rotation will come. Anti-clockwise rotation means, so you already know it. You will get it. If you taken like this is positive value, this is positive value. If you equate it, negative value will come. So theta b and theta c negative value. So you taken as a positive, so clockwise is positive, it is anti-clockwise. Otherwise if you taken this anti-clockwise is positive, these are the negative signs. If you equate positive values, you will get positive values. Yesterday I shown you. That's why I shown you. So stiffness matrix doesn't change. If you applied a now here I applied a clockwise rotation. If you applied an anti-clockwise rotation, the force is also generated in the same direction only. That's the idea. Are understood? If you taken like this, if I taken like this, otherwise I will show. I gave a clockwise rotation. If I gave an anti-clockwise rotation, it will how? It will come like this. Anti-clockwise rotation. The force is also generated in the same direction. That's why the stiffness matrix doesn't change. Are understood? Are understood? Is here also. If it's taken here also, it will come like this. The force will generated here also, here like this. So that the stiffness matrix doesn't change. Final values, sign will only change. Are understood? So that's the idea. So the same will get. You can find out, sir, without for knowing the 4x4 matrix, how we will get the remaining value, how we will get the final end moments. Only you shown only thetas. So now here you have to use slope deflection equations. So what is the slope deflection equation? MAB is what? Fixed end moment plus 4. So 2EI by L into 2 theta A plus theta B minus 3 delta by L. That's it. So MBA is what? Fixed end moment 2EI by L into 2 theta B plus theta A minus 3 by L. Those are the slope deflection equations. So you have to use it. So because see, these slope deflection equations only we related in the matrix form. Understood? So that's it. So directly you can take it as these values theta b and theta c. So for this theta a is 0, theta a is 0, theta a is 0, this value also 0. Directly place the theta b here. Fixed end moment is what? Minus 80. Minus 80, you place it, you will get it. What is you will get? You will get minus 85.938. That's directly EI cancel. This is 80, you will get 5. MBA also you will get 68.130. Once you get MBA, MBC also same thing. MB also you will get, MB also you will get same thing. MF you want write it 2 theta by L into 2 theta B plus theta C minus 3 delta by L. MCB is 0. You already know it. It's a field list. Here you can use, here you have to use theta B and theta C. Both you will get final value, you already know it, 69, but both are same. Because MBA plus MBC equal to 0. No need to calculate. Once those values you will get, you will write, you will do the bending moment diagram. Yesterday I write it, and later shear force diagram also. So what I want to say here is, so no need to write 4x4 and 4x4 and you have to assemble. No need to write to do a small problem. For a bigger analysis, finite element analysis, for a computer programming, you have to develop those matrices and you give a boundary conditions. That is the algorithm. That is like a 1 by 1 algorithm. That's it. That the way the computer will understand. Here is the only doing a small problems by hand. So many YouTube videos or otherwise in textbooks, small textbooks. Good textbooks, they will give a clear description about the matrices on how they assemble everything. They will give, but a small textbooks they will solve the problems like this. Okay, so this is the idea. Okay, you can do problem by your choice. By your choice. Okay, so see the 2x2 matrix will get like this only. I will say it's, if you strike out the rows and columns, you will get it. What you get, you can get by this method also. If you taken only these 2 degrees of freedom, only to get only these 2 degrees of freedom, also if you taken, you will get the same 2x2 matrix what we get in a total assemble matrix. That is the new idea. Okay, so that's thing. Now now we will go to the flexibility matrix. So I said flexibility matrix, you can't get it or you can't see in anywhere because that is a imaginary things. You can't allow those deflections, you can't get it, but is in imaginary way it is it is working, but you can't describe why it is, sir. I already explained. If you applied a unit vertical deflection, how much, if you how much deflection, how if you apply, if you applied a unit force here, how it will go like this. It is a not stable. It will give some deformation or it will give some rotation. You have to find here also deformation, here also you have to find certain here rotation. If you give unit force, how much deflection you will get it. That is the stiffness, that is a flexibility matrix. You can't find out because it is not stable, you can't find out those values, but it is workable in a computer program, something somewhere, some situations, but no one use this is else imaginary. But I said, if you arrest something, you can't find out 4x4 matrix, but you can arrest something, or you can arrest some this deformation, you can find out. You arrest this deflection means you will get a force. If you give a unit moment here, something unit moment here, unit moment, how much for ml by 6a ml by 3a, so l by 3a you will get here l by 6a, l by 6a you will get it. And also it is you will get it positive direction, you will get it negative direction, it is anti-clockwise. One is positive, one is negative. Otherwise, if you 4 by 4 matrix, you have to do inverse. Some of the values are negative. Understood? So like how is that? Like this. So if you arrest something, or do it is by making it is a determinate, not a determinate, by stable, you can get. So by flexibility matrix you can solve the problems only like this, only 2 by 2, 3 by 2. Some of these arrested here. Now you can see some of the forces are, you can arrest it here. If you see only rotation, there is no deflection, because you arrest something, vertical reaction, you can arrest it. Here only you can find out the moments. You can't find out the any vertical forces. So like this you can do it. I will show you problem. Okay, no problem. But how we will sir? How we will sir? Same thing easy. This is a flexibility matrix. These are the unknown forces. These are the fixed end moments here. That matrix, free deflection or rotation, free deformation matrix. Free deformation. Here you find out the forces. We have to find out the deformations. These are the final values. These are the final deformation. See, final deformations. So same related, you can relate it. Okay, so that is the idea. I will show you. Now we will enter to the flexibility matrix. I said once again, there is no possibility to get the 4 by 4 matrix. Otherwise you have to do capability. Those 4 by 4 matrix, you will get it inverse. Exactly, that's inverse. Okay, now I will shift to the flexibility matrix. In flexibility matrix, there is no assemble everything, that nothing is there. We will do the problems like this only, if what I did today, that only you can do it. I will solve the same problem, then you can understand. So in flexibility matrix also, I said it like how it is how it is like, so delta final deltas is equal to the flexibility matrix and forces plus fixed, not a fixed, free deflection diagram. Free deflection. What I write exactly here, same thing. So where the forces will there, now we can take as a deflections or deformations, because vertical deflections and rotations are there, both are there. So I can call it as a deformation. Where the forces are there, it's a deformation. So in the forces here only at in the matrix form. So same thing here, in the matrix form you will get deflections. This is a force, unknown forces, the unknown forces. Here a free deflection diagram. Final deflections, here also you will get 0 0. Here also final deflections you will get 0 0, because if those are the deflections, you arrested here. Those are the deflections you arrested here. I will show you. So same thing you will take as a similar way. Just do 1 2 3 problems, you can observe it. Otherwise you can see in a textbooks, you can clearly replicate it or just inverse. So for the same problem I will show you. For the same problem I will show you. I will show you 160 kilonewton meter. See, now how much degrees of freedom is there? Not a degrees of freedom. How much statical indeterminacy? Statically indeterminacy 3 1 1 5 minus 3 is a 2. Otherwise if you release the horizontal, it's a 2 1 1 4 minus 2. horizontal equilibrium equation also you can remove it. It's only 2. So what are those two? What are those two? What are those two? Okay, what are those two? That is the question mark. 1 minute. See, now you can see what are those two unknown values. So that is the question. That is the also here as a problem. So what is that problem is, you can take these two reactions are unknowns, VB and VC. You can take those two are unknowns. That means what? Those two are unknowns. If you release those two, it will determinate. That is, 2 is the indeterminate. 2 is the statically indeterminate. 2 is the static indeterminacy. Static indeterminacy is 2 means, static indeterminacy 2 means if you release those two or if you remove those two extra redundant forces, it is a determinate structure. So what are those two? Previously, if you taken a degrees of freedom, you directly said that it's a 2 degrees of freedom. What are those two? Theta b and theta c. There is no other choice. But here a choice is there. So why? Because extra 3 will come. Extra 2 equations will get from a universal equilibrium equations. So here if VB, VC, you can take it as a unknown reactions. That means if you release those two, it will like what? It will like a cantilever beam. It is determined. It's directly determined. It's a cantilever. Otherwise, we have another choice also. What is the other choice? Other choice is this. What is that? This MA, this MB. This MB means maybe this is, you can take it. This MB, this MB, this MB. MA and MB you can take as a fixed, those redundant. If you know this VA and VB, you can, if you know those VA, VB and VC, you can later you can find out MA and MB everything. If you know those two unknown redundancy, VB, VC, you can find out remaining. Otherwise, if you know MA and MB, if you know the MA and MB, you can find out remaining VB and everything. You can find out MA and MB. So here, if you release those MA and MB, if you release those MA and MB, if you release, or if you find out, or if you release those two, how it is? If you release MA and MB, it is a simply supported. If you release MA and MB, it will go simply supported. Understood? So this is also you can find out without without getting any another equations. These are also is a simple supported beams. Two simple supported beams. Here we remove MA and MB. Moment is released if you release the MA and MB. Here you can release VB and VC. So what are those unknown? What are those two static indeterminacies? What? Either it is MA or a VB or VC or MB, anything. Because those two universal reactions, universal equilibrium equations will come from universal. Here the choice of redundancy is anything. The choice of redundancy is anything. If you release those unknown, if you release those static indeterminacy, it will become a determinate, same as previous. If you arrest those 2 degrees of freedom, it is kinematically determinate. Here also, if you release those 2 indeterminacy, it is a statically determinate. These are the statically determinate. Statically determinate. Here also statically determinate. These two. But the problem doing what we have to do, sir. So previously we taken as a 1, so 2 degrees of freedom is 1 and 2. We taken as 1, 2 is a node. No, it's not a 2 directions. Here what we taken, sir? Either we have to take MA and MB or VB and VC or MA and VB or MB and VC. It's a probability of combinations, sir. So there is no fixed. There is no fixing in the choosing of the static indeterminacy. So that is also one problem. That is also a problem. That's why it's not it's not a simple algorithm. It's not a simple algorithm. So that's why also in a computer programs the flexibility matrix doesn't work. there is no fixed format. There is no fixed format where what is we get taken as a what it is taken what which one we have to choose a redundant, either MA and VB and VC, nothing. So anywhere, so there is no fixity. You can't take out the, you can't, that's what's it, you can't write down the assemble of matrix and you can't eliminate remaining and you can only 2 by 2 matrix. You can't do, you can do it, you can do it by choosing something, but there is no fixed way. I understood, there is no fixed way or compulsory these two only redundants, nothing. You can choose anything, you can choose anything. Are understood? Previously also in the solving of here, so proper cantilever, one is the fixed, only one is the static indeterminacy. The only one is what, one is either you find out the VB, or if you know the VB you can find out this value. Otherwise if you know the moment, what is, if you know the moment here, you can find out VB. So you have to choose MA is redundant or VB is redundant. Which one is redundant? Anything is redundant. Anything is redundant. Any one of the fours, if you know it, remaining you can find out. Understood? So that is the problem in the static indeterminacy, in the flexibility matrix, formation. Understood? So that's the another drawback in the flexibility matrix. Now you can see. I will do the problem in the same these two way. If you require, I will do the same problem in two different ways also. We'll get the same answers, no problem. Okay, so I think it. So what we will do, sir? Now what we will do? First you have to find out which two is taken as a redundant forces. So now I will choose that MA and MB is the redundant forces. If you release those redundant forces, how we will get? So now I will strike out this thing. I will choose MA and MB. I will choose MA and MB as redundant. So if you release those two, MA, if you release MA, you will get hinged, and MB also redundant. If you taken as a taken, if you know these two will form is, these two will form. Are understood? That's it. If you release those two, you will get like this. Okay, that's it. That's the first idea. Next, you have to find out the fixed end forces in the stiffness matrix. Here fixed and deflections. Are understood? Fixed end deflections means are what? Same, you are understood? At that location you have to find out the fixed end forces. Here fixed end deflections. So you choose two deformations, you choose two indeterminacy. What is MA and MB? For this application of the load, what you applied here, I applied a load here. You have to find out the fixed end rotations. Fixed end rotations means what? For that application of the load, how much rotation is allowed here? How much rotation is MA? MA means here is MA is taken as redundant. In the same direction, you have to find out what is MA, what is the rotation here, theta A. Final theta A rotation is 0. Already know it. Final theta A rotation is 0. So that's why final is 0. Because you release this MA, you will get theta A. Later if you arrest it, so finally going to be 0. Finally you're going to be 0. At the same thing previously also, first at the theta B location, we have to find out the moment at that location when we arrest the deformation. Later through the stiffness matrix we release it. Application, applied load and reaction, both will club it together, is equal to 0. That's it, na? Here also same thing. You have to find out the theta A and theta B also, and theta B. You have to find out, because only thetas, no need to delta, sir. Why? Because you choose in MA and MB. For this case, you have to find out delta B and delta C. Because see why it is, if you release for this location you have to find out delta B and delta C. Later you arrest those deformations. See, these are the fixed, not fixed, as supports. Later you arrest those two. Finally we'll get 0 0 0. You have to equate 0 0. Understood? That's it. That's the one question. Okay, I will do that part only today. Remaining part I will do tomorrow. So how can you find out the theta B, theta A and theta B? Theta B and theta B. So you can find out directly by, if you know it, you can find out. So simply supported, it's a simply supported beam. What is that? WL by, I think I understood. What is that value? Simply supported beam deflect WL square by 24A something. But if you remember, if you know the formula, do it. Otherwise follow one simple method. What is simple method? Simple method is conjugate B method. So what is the conjugate B method? So conjugate B method is, so directly what is the bending moment diagram? Bending moment diagram is for this load. Bending moment diagram is what? For this load, bending moment diagram is what? This is the bending moment diagram. What is that value? WL square by 8. WL square by 8 is what? This is a 60. 60. L is what? 4 square by 8. So 4 cancel. 2 cancel. So 120. 120 by 8. If you just place the bending moment diagram, not a bending moment by EA. M by EA is a curvature. Just curvature, you place it. And you find out the shear force in this direction. Shear force at this direction, you will get the rotation, or bending moment you will get it. What you will get? You will get bending moment. If you get it, you will get deformation. Deformation you will get it. That's it. So that's it. Same this hinge support, you will also hinge support. Here is a hinge support. It's a hinge roller will hinge. So both are the same property. Okay, here also if you see it, write down the bending moment diagram. WL by 4. So WL by 4. So what is W? Is 100. L is 3 by 4. So 25, 75 by 8. 75 by EA. So directly, what is this value? Shear force. What will get? Off will come. What is exactly here? What is that? Theta A. Otherwise you can write shear force. Later it is equal to the rotation. You may write it directly. What is rotation? Off means what is total load is what? 2 by 3rd of 120 by EA. Multiply with length 4. That is the total load. In the total load you will get off. So what is that value? That value is 160 by EA. 160 by EA. Okay. So that is the theta A directly. So what is theta B? So for theta B, you see it. For the rotation in the theta B, rotation will cause by this load and this load also. Both will give theta B, because the theta B is a joint. Understood? Theta B not only getting by this and not only by this. Both are the combination. Okay. So for this load, how much theta B? If I call theta BA, I call it as, this is for theta B. Theta BA is same amount, because exactly half will shift to this load, half will shift to this. For this it is exactly 160 by EA. For this shear theta, I think it's called as a BC. I write like this. So what is that value? Off. Exactly off. Off means it's a 1 off. Exactly off. Off of the 75 by EA multiply with 3. That is the total load. On the span. That's in off. Off will come to this location. So this is the value. What is that value? So 2 doesn't get multiplied. Okay. Now it's finally is a theta B. Theta B is these two combination. Are understood? These two combination will get it. So what is that value? That value is 216.25 by EI. So these are the two fixed. These two are the fixed and not a x fixed, not a fixed. Previously it's a fixed. It's a free deformation values. Free deformation values. You have to find out the theta A and theta B. You have to find out the theta A and theta B first, and later you restrict it. You just, it is a free. If you just, it is a, you just did it is a, just a feeling it is. You just did it like a simply supported beams. Later you arrested here by MA. Sir, here we don't arrest it, but you don't arrest it. I said it's a MB. You don't arrest it. You get a theta B value, but it's a joint behavior. Are understood? Finally, you will get by the flexibility matrix. It will nullify it. You will get 0. You will get 0 values. Okay. So first, this is by a free body. That is it's divided into statically determined structures. You will get these theta B and theta C value, theta A and theta B values. By the flexibility matrix, you will get exactly opposite. They two complement each other. Finally, you will get 0 0. Why it is 0 0? As a stiffness matrix. Stiffness matrix, you saw it exactly related to same matter to this. Exactly related to same matrix. If I directly taken a flexibility as the first unit, you simply confused, or simply you doesn't understand. Only I will write how to do problem. This is a formula. This is doing. But if you relate with the stiffness matrix, what I said previously are exactly related it. But it has a flaws. In flexibility matrix, it has a flaws. So what you see, okay? So later, tomorrow, I will develop the flexibility matrix. Later, I develop the flexibility matrix. What are those unknown factors we taken as MA and MB? So equate to 0 0, you will directly get the MA and MB. Once you got the MA and MB, you will remaining values, you will get it. Are understood? So I will do tomorrow for this type, and also I will do the same problem in this type also. Now you can understand the way. Okay, are understood? So that's the idea. So now I will stop here. Tomorrow class I will, so for that you have to understand the stiffness matrix better way. If you related those the same, if you relate the same thing, see this I will write here. Previously, final forces, stiffness matrix and deformation deltas. So fixed end force, fixed end, here a free end. So exactly same na? Opposite, inverse. Stiffness matrix of inverse is flexibility matrix. Exactly opposite. Here is a fixed, here is a free. Here is a flexibility matrix, stiffness matrix. The unknown forces, unknown deformations. So these are the final. So these two are complement each other when there is no fixed end movements or fixed end load. That is at the joints there is no loads. Here also these deformations will 0 when there is no deformations at that locations. But if somewhere you already know it, maybe you already know it, support B is settled by 1.5 meters, support C is maybe fixed, support C may be free. If I applied a load here like this, so final where it is, final it will go like this. Finally it has some deflection. Finally it has some deflections. Maybe final deflections is something, maybe is there. If you know it, okay, you can directly write it here. Here also stiffness matrix also, some of the cases I already said, some of the cases maybe its joint moment is 100, the final moment is there, exactly that value. This value is already known values. Here also the support is settled by 1.5 mm or 2 mm. These are the known values. You have to equate those known values. I will do the problems also, I will do that problems also, one by one. Okay, so that's it. First you have to understand, you have to relate these two, you have to relate these two, then only you can understand. That's a good idea. Okay, I will stop here. Just take a time and understand it. So I will do the problem tomorrow. That's it.